We're going to go ahead and get started again. We have joined the panel now Grady Sladen. He's with TASB, Facility Services. I think South Central is his area. Is that correct? He has to make sure that he hits College Station. I think it's his primary goal in that. But what we're going to start moving now into a little bit of maintenance things. I know there was some technical jargon used earlier, and we'll try and limit those. But this panel, we all have jargons in whatever line of business we're in, but we'll try and be careful of that, and I'll try and catch those. I think one of them was NRCA. Hit that, Scott.
National Roofing Contractors Association.
So National Roofing Contractors Association. Another question came up about, I think Scott mentioned Class 4 roofs. We're going to talk about that a little later, but there are classes of roofs based on, the characteristics that they have as far as, wind, hail, and that sort of thing.
Depending on whether it was United Laboratories that may have conducted the tests, or Factory Mutual, which is another independent agency that manufacturers will pay to test their products under very strict guidelines, repeatable guidelines to evaluate performance characteristics.
Yeah, and we'll get into some of that later, and you'll hear UL, which is United Laboratories, or FM, which is Factory Mutual, but we'll talk about that and try and remind y'all you don't have to memorize everything right now. But for now, with Grady, I want to talk a little bit about, I know we're going to talk about roofing procurement later, but Grady, you've just taken over in your school district, your city, and you're the maintenance guy, and you have a bunch of roofs. Does that cause any problems for you, or what are you going to do with those roofs? Do you ignore them and wait till something happens?
That'd be nice, and unfortunately, that's how they're handled a lot of times. But really, being an owner of a roof or any system begins at the beginning. To be involved, especially from a maintenance administrator perspective, at the very beginning when you're talking about system selection and specifications. The specifications of the type of system, how it ties into the rest of your building, the walk paths, ladder access, all the different material specifications, how it's adhered to the structure, the supporting boards underneath the insulation, everything. Be involved with that process. We've got some great contractors. We've got some great products that's available to us as owners, but eventually it's going to be the owner and the roof. And so understanding what you have there and making sure that it meets your department's needs, your organization's capabilities, is extremely important. Then it moves into the installation process, making sure that you're involved as the system is being installed, that the specifications are being followed, and that everything is being met in any testing or periodic inspections. I'm a big proponent of a roofing consultant, whether that is an architect that has extensive experience with building envelopes, or someone that just specializes in a roofing design. Big proponent of that. They bring a level of expertise, because as a maintenance director or maintenance administrator, you may deal with roofs about every 10 days when a thunderstorm comes through, and you're scrambling folks to deal with leaks, but they deal with it on a daily basis, especially on the installation and material selection side. So being involved in the installation process to make sure all the steps are being followed, all the specifications are being met. And then the punch process, getting up there and walking the roof. Even if you're not performing the punch, if you have a roofing consultant that's doing it, walk beside them, educate yourself as much as possible. As the owner, you've got a responsibility to understand what's going on your roof. From the punch process, you're moving very quickly into the closeout. You're getting your warranties, the recommended maintenance processes that the manufacturer recommends, even to the training for your staff as applicable for proper maintenance and repair techniques as needed. From there, you move into regular inspections. Once a roof goes on, the next time you go on that roof shouldn't be just because you have a leak. Periodic inspections to check the condition, the cleanliness, and then that leads into your regular maintenance efforts. Cleaning the roof, removing debris, trimming the trees or tall shrubs that might be up against the roof. So it's all a very involved process, and yeah, it'd be nice if you could just throw a roof on top of a building and you didn't have to think about it for about 20 years, but there's a lot to it.
Yeah. And I know, Scott, you've worked in the past with large retail operations and who know a thing or two about saving money and making sure they can pass those savings on to their customers. Do they have roof maintenance programs and pretty zealous about it?
They are pretty zealous, all the way down to items like keeping an actual log of every single person that goes up on that roof through that access, signs in and signs out. That way, if you go up there to do your semi-annual inspection, your quarterly inspection, you find damage up there, you're much more likely to know who it is. More importantly, not for blame, but for education of the contractor, so it doesn't continue to happen over the next 2, 3, 4 years where it develops into even a bigger issue. But keeping those logs, keeping the historical data on your buildings. Most everybody in here is a multi-facility owner where you've got 2, 4, 20, 200 buildings. It's important to know what you have on that roof, who installed it, when it was installed, who and what warranties you have in place. One of the things that was amazing to me with one of our largest clients who had some, I think it was at the time, 1,800 roof warranties under their possession. And on some particular buildings that were brand new construction, they had not opened yet, were paying thousands of dollars to hire a contractor, repair contractor, to come out and repair leaks, even though it was under a contractor's warranty, a manufacturer's warranty. The warranty had been issued a week earlier. So it's critical to know what you have, who put it on, when it was put on, when it will expire. It's not complex to keep some of those data points, and it can do wonders for you in making that roof a 20-year, 30-year, or even a 35-year asset if you take care of it properly.
Yeah, and we're going to talk even more about warranties later, but speaking of maintenance, Lane, I mean, obviously people call you and say, my roof failed, must be because of your product, come fix my roof. And how often do you go up and in truth find it's not that your product has failed?
It happens, and it happens generally. To Grady's point, people put on a roof and they forget about it, and they don't go back up there until water's coming in, and sometimes like water's in the basement. And you're like, really, and you think that's the roof, but when then you go up and it can be something as simple as drains that have not been cleaned. And when we talk about maintenance from an owner's perspective, think of it like changing the oil in your car. You don't buy a car and drive it for 100,000 miles and expect it to perform. And roofs are the same way. And Grady made an important thing about inspections, routine, twice a year. You go up in the spring and you see if there are any problems, because then you have the whole roofing season to address it. And then you go up in the fall to make sure you're ready to go through the winter. And when I say go up, one of the recommendations, I brought with me this manual for inspection and maintenance. This one was built up and modified, but it's pretty much the same for single ply. But it was co-authored by the Asphalt Roofing Manufacturers Association, ARMA, and the NRCA, the Contractors Association, National Roofing Contractors. And it's real interesting. Basically, what they say about inspections for building owners, so all of you, is go up and look, and if something doesn't look right, call a roofing professional. It's that simple. But when we look at warranty repair, calls for warranty repairs that are actually maintenance, oftentimes it's either inattention, they just didn't keep drains flowing, or it's debris on the roof, and especially schools, it's amazing the things that can end up on a roof, or which then are clogging drains, or it's other trades. It's the HVAC guy who came up and, took off and left, doors off, panels off of an HVAC unit, and now water's coming into the building. Or they weren't, the HVAC units, the doors weren't properly secured, and then you get this wind-driven rain coming in. So it's general things like that. Now, most roofing manufacturers are very gracious the first couple of times you call us out, and we point out that it's really not the roof, that it may be something else, or that this needs to be done. But take care, because oftentimes even the warranty language has got if you keep bothering us, we may charge you to come out and just be your troubleshooter for things that aren't roof related or are your responsibility. There's one other thing. We're going to get into it later on warranties, but I'll mention it now too. Little problems only escalate and become bigger problems. And we're going to talk about what can cancel a warranty. And this is where we get into that. If you're not maintaining the roof, it's probably going to be the biggest cause of finding that you don't have coverage, whether the warranty is canceled or something is not specifically covered. And the damage that then continues to grow is also then may not be covered. Okay?
And Jim, I suspect you as a contractor gets called out often and asked about problems. And do you find maintenance to be a common problem?
Generally, the number one problem. So if we've installed a roof, generally we're going to get the first call on a leak. And then we're going to go up there, we're going to look at it, we're going to figure out what happened. If we think it's a material issue, that's when we would call in Helene or one of your field reps, to take a look at what's going on. But most everything we find. So in the life of a roof, if a newly installed roof on the first, second, or third rain, there may be a leak or two. That's generally going to be my problem. We've missed a detail. You have a roof with 100 penetrations on it, and generally it's going to be a detail. It's handwork, and there's going to be human error. After that, generally what we find is it's going to get more into maintenance, clogged roof drains, clogged gutters, a careless HVAC contractor who does some mechanical damage to the roof membrane, and then late in the life of a roof, then you start seeing failures with sometimes sealants and things like that need to be touched up.
Right.
So
good. And so again, just kind of summing this up, you can't just put the roof on, forget it. Maintenance is such a critical piece. It helps you not only maintain it, but spot problems before they become big problems and show up on the inside of your building. That's where you will stop them on the outside, not on the inside, because then you have other damage to fix. And frankly, from a coverage perspective, you may not have coverage for that as well. I'm going to talk a lot of coverage, but maintenance generally is not going to be a covered peril under most coverages. So, all right. Some of this next topic we've talked a little bit about, and that's okay, because it is so important. Kind of now move a little bit away from maintenance, but it is related to it, kind of the life expectancy of a roof, and what you should expect and what you can do to have a longer life. And I know one of the topics on here is, and so y'all can expand a little bit on what you talked about earlier, but thinness, thickness of material, the things that really impact that life expectancy, whether it's how it was put down, type of material chosen. Elaine, do you want to maybe talk to some of that? And I know
I'll
Scott
kick
may
it
or
off.
may not
I'll
have
kick
an
it off
opinion.
and see if I can stir up some interest amongst the panel members. And to our friend in the back, he was 100% correct. It's not just the membrane; it's the system. And so we've been talking about membranes and being very membrane centric, But when we talk about the roofing system and life expectancy, it's about starting with a good, solid foundation, and then it goes into the membrane is, yes, the weathering surface. So what are some things you can do in terms of life expectancy? We want to reduce the amount of stress on the membrane. So a double layer of insulation with joints staggered. And we're going to talk about extreme weather events, but a cover board that is the top layer, your base underneath the membrane, that is what I call a hard board, be it a gypsum-based or a high-density ISO or a high-density wood fiber, but something that gives you a very strong foundation. Making sure that it's all fixed in place well so that we don't worry about movement, okay, is another thing. Then we get into life expectancy of the membrane itself. And it's this simple. When we talk about maintenance, we actually have, and other manufacturers have, working with roofing contractors, that if you do routine maintenance, we expect that roof to last 5, 7, 8 years longer. And there even are guarantee extension programs that may be available that recognize that. It's as simple as going up and looking at it twice a year and making sure everything is the way that it should be. And my friend Jim here reminded me of, things that are maintenance items like pitch pocket sealants and fillers and caulking along receiver lips on flashings where, you terminate at a wall. If you maintain those things, when we talk about life expectancy, you've just extended it that much further. So if we can reduce the stress on the membrane, if we use thicker membrane so that we have a more wearable material, we start to talk about 20, 25, 30-year type of roofing systems, if it's all done correctly. And that's with the caveat that we've not built in failure. So building in failure is like building in moisture. It's putting a roof on a swimming pool without a vapor retarder, okay? It's putting a roof over a poured-in-place lightweight structural concrete that you never accounted for where that water is going to go, and you built a whole bunch of water into the system. So that's the caveat into life expectancy of the roofing system, is that all of those things are accounted for. And now I've just scared the whole room and giving you a good reason that why you need to be talking to roofing professionals like Scott, who understand those things up front in the background. So.
Well, and right along with that is, hey, designing a roof system where I can quickly and efficiently, that system's going to move that water that hits that roof off the roof and away from the building. Simple things like crickets on the backside or high side of AC curbs. And once again, doing them in a way where if I'm going to spend the money to invest in a very dense, very thick, rigid cover board, making sure that that is what's over or underneath the membrane and isn't the cricket under the membrane in those locations. Making sure that when I have base flashing terminations, I'm always counter flashing those. We get into so many times where we stop, contractor puts a term bar on, caulks it, walks away, we get through the first 10 years, but guess what? All of a sudden we're running into places where that caulk's wearing out. We counter flash it, we just took the UV off it for its life. Now it goes from being a maintenance issue to being a non-maintenance issue. So looking for ways to make that roof work with that building in unison and make it as bulletproof as we can. And many of the things we're talking about, skirt flashing, proper placement of insulation assembly, looking at fully adhered perimeter walls. That's going to beef up your wind resistance versus mechanically attached. All of those little things can add up to big dividends in the end on how that asset and its life cycle extends out for both you, whether you're a school, whether you're a city. Those are all huge issues, and it expands the window of success for the contractor in the process.
Yeah. I think if I could add, I think you can extend that work even more when you're replacing a roof system The forensic investigation that needs to happen on your existing conditions is extremely important. Is the roof decking solid? I think we've all probably seen or heard of examples where we thought we were just going to tear off and put on a new roof, but you tear it off and the roof deck is rotten. And so that certainly is a budget impact. But then getting into improving the existing flashing systems to where maybe now you have a through wall flashing and getting those systems installed as well. So dealing with roof mounted equipment or pipelines, roof supports, roof pads, all of that goes into, especially on a roof replacement, and making sure that your roof designer, your consultant, is doing that forensic inspection and evaluation of the existing conditions.
One quick note that you did remind me of, that we've seen more and more of this as part of that maintenance plan, is understanding when there's enhancements or activities with that building after that roof was put in during new construction, whatever the case may be, making sure that things like conduit don't get run up against the underside of a deck when we know that potentially we're going to have to run fasteners down the road through that deck that will now pierce those items. Being smart with those choices, that's part of that compatibility, whether it's in the new construction phase or the maintenance phase, controlling your contractors so that they don't inadvertently create an obstacle or hazard for you or others down the road that could significantly increase the cost or significantly increase risk, which will do both.
Yeah, and the other thing is, you kind of mentioned is that change, but sometimes you may have inherited a building that may not be perfect in design, and when you put that new roof on, that may be your opportunity to fix some problems that weren't perfect before pretty economically and cheaply while you're doing it. And I thought Jim made a point earlier on maintenance that can easily be overlooked, especially you guys that gals are in charge of buildings. You only have to be an expert in electricity, plumbing, roofs, construction, foundations, everything, right? When you get that roof put on, whether it's like with Jim or a guy like Scott or like Grady, have your folks walk that roof with them, and they can help point out those features and the things they need to be looking for on those maintenance. Because you guys have a lot of hats that you wear and a lot of things to do. Use that professional who put on your building, or it may be a manufacturer's rep out there. Help them educate you and your folks as to what you need to be looking for. Because you can go up on the roof all day. If you don't know what you're looking for, it's just a trip to a hot roof.
I wanted to point out something. Grady, you reminded me of when you're doing re-roofing and you have a roofing professional, a roof consultant, or an architectural firm, and they're looking to help you upgrade so that you're designing to extend the life expectancy of that roof. Take care that you support your roof consultant or your architect, in that they may actually be specifying a detail that is beyond what the manufacturer requires. And I have always been adamant that if someone specifies more than, we will always support that detail. That's their design, and they're doing it for a reason. Unfortunately, sometimes people will be like, oh, well, we don't need to do that to get the guarantee. And that's just is shortchanging you as the building owner, and it's shortchanging the expectation of how that roof should perform. So take care there. And it's real funny because I'll end up butting heads with roofing contractors who are like, but Helene, you don't require us. You'll allow us to use a term bar for, a 15-year guarantee. And I'm like, yeah, but they put in counter flashing. That's how you should have bid it. So.
Good point. All right, let's kind of move forward a little bit, because now we want to talk about, we kind of hinted at some of this earlier, kind of testing standards and what all this means. What's class 4? What does severe mean? What does FM mean? That sort of thing. So, Helene, if you will, talk a little bit. I guess you at JF, y'all just get to say whatever the roof is and you slap a label on it and send it out the door. And is that the way it works?
Not exactly. So So we have an entire team that does what we call product and system certification and testing. And when we look at I'm going to talk about low slope. So let's talk about this. Let's go back to steep slope. When you get a bundle of shingles, okay, that shingle will have a label on it. And it'll say UL blah, 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 790, and it'll say Class A. Everything's pretty much Class A today for fiberglass shingles, asphalt roofing shingles. But it'll say Class A. First off, there's no such thing as a Class A membrane for low slope roofing because it's tested as a system. I hinted at it earlier about PVC and real high slope. So the system is what's classified. In roofing, generally, we're talking about surface burning fire, A, B, or C, and the building code, A, B, or C, and you get into building occupancies and what rating is required by building code. We also classify for wind uplift resistance. Generally, that's done either at a place like Factory Mutual Approvals or at like PRI is a testing agency. Here, there's a couple here in Texas, but those, people talk about FM approvals, and generally they're talking about wind. But an actual FM listed system that you'll find in RoofNav has got all types of other stuff. It'll have hail, it'll have weather resistance, it'll have internal and external fire. External is the same as UL. It's ASTM. It's an ASTM standard or the UL standard. They run kind of lockstep. And internal fire is what we call a calorimeter test. So those are all system testing. What's critical to understand is it's the system. And so it's not membrane. It is literally from the deck up. On fire, decks are just either combustible or non-combustible. But when we start talking about wind resistance, we're talking about not only the fact that it's a metal deck, but we're talking about, is it 33 or 80 KSI, 22 gauge metal deck. And so, or we're talking about things like, not just lightweight insulating concrete, but specifically what type. And so when we talk about these systems, so fire is easy. Wind is in pounds per square foot of uplift resistance. There is no mile per hour, and anybody that says an I-90 is 90 miles per hour, they're wrong. Okay, so you put yourself up on your pedestal and say, I know that they're wrong, because that 90 is the pounds per square foot of uplift pressure resistance. How that all ties together is we look at the wind resistance requirements in accordance with the American Society of Civil Engineers, Standard 7, ASCE 7, which gets really confusing because there's now 4 versions of it, 5, 10, and 16. And you get different results. But generally, a rule of thumb is if the building is less than, I say 60, but 30 feet, 2 stories, a 2-story school, and it's not on a coastal area, 90 pounds per square foot is probably going to be code compliant, but just reach out to people, the roof consultant, they can run the calculations. But it is the system. Now, in terms of where do you get performance? Wind is always the weakest link. So on a mechanically attached membrane, the membrane carries the load. I don't care about the insulation underneath. I don't care about the pre-attachment of the insulation. That membrane is your point of failure. The fastener is either going to pull out of the deck or the membrane is going to tear around the fastener. That is your point of failure. When you talk about fully adhered doesn't peel off. It just doesn't. Unless, like, an edge fails. Generally, it's the attachment to the substructure. So it's the mechanically attached insulation underneath. The fastener will pull out or the insulation will pull through. But fully adhered generally is going to give you higher uplift resistance. And then it's very deck-centric. For wind resistance, give me concrete all day long with a parapet wall and it'll ride out any hurricane, okay? And let me just put that in perspective. We own a timeshare on St. Martin that was hit by 200 mile per hour sustaining winds 2 years ago. It has a concrete deck. Every time they have a hurricane, the Dutch military stays in our timeshare because the building is still there and the roof is still there. So concrete deck with parapet walls from a wind resistance standpoint is really going to give you your best base. So I went way too deep, but I'll turn it over to somebody else. Did I kind of cover what you wanted?
You did. And Scott, maybe talk a little bit about, the hail resistance and how you design and what you look for.
Yeah, thanks. It's very similar. A lot of the systems that we deal with referencing Factory Mutual. Factory Mutual has testing procedures. Manufacturers will submit their assembly, which usually is comprised of the overlay board, say a DENS deck or something like that, with the membrane over it, mechanically attached or adhered. They will then expose that to 2-inch ice balls at certain velocities. They will test both a non-aged sample as well as an aged sample in accordance with the standards. Based on that exposure and evaluation, they will classify that membrane as very severe hail or severe hail or moderate hail. Most of the systems that we work on with clients here in the Texas area, a bare bone minimum is severe hail certified assembly. In a lot of cases, we'll even try and get to a very severe. Very severe is very difficult in Factory Mutual. I think there's currently about 300 assemblies that are listed last time I checked. It's a little bit more difficult because Factory Mutual not only looks at the membrane, as I recall, but they're also looking at whether or not there's any breaks in any facers of the underlying board. It makes it a much tougher hill to climb because now you're evaluating both products, and if you get any break whatsoever in that facer of the DENS deck board underneath it, that could be reason for failure.
So let me just I'll share with you some research that was done in a paper that was presented, peer-reviewed paper. It's simple. Hail resistance generally is not membrane-centric. It's not. It has everything to do with what's underneath the membrane, or a lot to do with it. So Scott is absolutely correct. You're going to get a severe hail rating when you have insulation covered by a rigid board. There is one key, though, and we get this question all the time. Building owners want to cut corners and save costs. They do not want to fully adhere. And so they'll want to go to something like that heat induction rhino bond system, or they'll want to save the labor cost and mechanically attach all of the insulation, including that high-density board, at the same time, and maybe adhere to that. It is simple. If you do not bury that fastener anywhere that hail hits, a direct impact on any single-ply membrane over a fastener, if it hits where there's a fastener, it will puncture the membrane. Is that simple? It's that simple. So for hail resistance, and the way you get to a severe hail rating is you use a high-density cover board, and you bury the fasteners, and you use a fully adhered system. You can improve the performance by going to something like fleeceback that'll give you something that can absorb energy. Scott also made a very important point. When you get to a very severe hail-rated system, now you have to be a little concerned about, okay, great, it's going to perform well for hail, but how is it going to perform otherwise? Because we're having to do some interesting things like OSB or plywood underneath the membrane that may not, I kind of have been having ongoing dialogues with my friends at Factory Mutual approvals about, are you giving me, though, a roof that's actually going to perform for other things like keep water out, other than perform against hail? And so take a critical approach to what may have to be being done to get that very severe hail rating. Jim, you may.
It's a very delicate balance, and what you're seeing or listening with what she's dealing with is very true. Are we starting to introduce new hazards and risks in an effort to achieve one,
To pass the test.
and we're now creating a new risk over here. And so it's been a challenge for the whole industry to make tests of assemblies representative of real-world conditions, as severe as they may be, but also make it a test that is truly predictable of that particular product over a long period of time, 2 decades, which is the other challenge, predicting something on how it's going to perform after it's been in place, gone through the stresses, the environment, the exposures for 2 decades. Will it still pass that rigorous test? So it's a difficult.
Well, that's something I was wondering was if it's been FM severe or very severe hail rated, let's say, how long does that last? Is that good when that system is 15 years old?
You mean the rating?
The rating.
Yeah.
Is it still considered very severe or
I
severe hail
agree.
rated 15 years later?
Do an aged and a non-aged.
Yeah, okay, so
Theoretically, it's supposed to.
FM does accelerated weathering of the samples, but probably the best data that we have is there's an industry organization, the Roofing Industry Committee on Weather Issues. It used to be wind, but they've done hail investigations. The most recent, I think, was in Oklahoma City, and those are published reports. And you can go to we call it RICOWI, RICOWI. You can go to their website, and those are available for download. So you can actually read those reports. Generally, what you'll find is those roofing systems that were installed, as we've described, over a hardboard with thicker membranes, they actually have performed relatively well. Scott also pointed out where you'll see damage is oftentimes not necessarily in the membrane, but in the substrate. So if it was over something that wasn't rigid, you'll see fractures in insulation without a cover board. The other is in gypsum-based products, the gypsum base itself will fracture. And so, but that's really from a long-term perspective is probably some of the best information on how things perform over into the future, because they are generally tested as manufactured and then with that accelerated aging.
Jim, did you have anything?
Well, Helene you're absolutely correct. I can take a 0.6 membrane and, your company can either issue a 10-year warranty or a 20-year warranty, and it's not the membrane, it's always what's underneath it. When we go and inspect a building after a hailstorm, if you have a TPO roof that was subjected to, let's say, 2-inch hail, you're going to find your issues with the ones that where you actually have active leaks, where you have a fan fold insulation as the substrate, or you have fasteners. You'll see issues and leaks there. The harder the substrate, the better the roof. I agree with you 100% on the fasteners. That's always, get rid of them. That's where you're going to spend. That's going to be a wise upgrade, is using adhesives instead of mechanical.
Hey, Jim, can we level set with the terminology? So when you say, is substrate and cover board this interchangeable, is that the same thing?
Yes.
Okay.
Yes.
Okay. And that's what's directly, so you got the membrane, then underneath it is the substrate or cover board, and then you've got and then you've got insulation underneath it, although sometimes you might have the membrane sit on top of insulation?
Yes.
Okay.
Yeah, you're referring to substrate to the membrane or substrate of the building. So your building substrate is going to be your deck, your insulation if there is any, and then you've got a cover board or substrate to the membrane.
Exactly.
Got it.
All right. I think we're pretty much right at lunch. I want to see if there are any questions from anybody in the crowd about this. I think everyone is looking up those papers you referenced, and so they're reading those, and so we've now lost them.
If you have trouble finding RICOWI, that's a great resource. They do a study on just about every major event. Phil Drager was involved in that for years. I don't know if he still is, but you also might find it Rakowy/Drager. I think he's led several of those teams and committees.
Yeah. So I think we're at our lunch break, but I think in summary here, I think what you heard is that it's not just the membrane, it's the system, and you need to talk and look at what are you using your building for, what do you need out of it, and then you design that system that meets, maybe it may not meet every single need, but it meets the vast bulk of the needs that you have. And so sometimes there are compromises, but you do have to design and you have to think about it.